Welcome back, everyone. In this math paper, we're going to do some more in speed. If you remember, velocity is rate times time. And you have to ask yourself, is that speed accelerated or not accelerated? If it's not accelerating, if it's non-accelerating motion, then it's all to the first power. It's not based upon the square of time. It's not 2 times or 4 times or 9 times or 16 or 25 or 36 times more. So it's not getting bigger and bigger and bigger as it's going. It's just increasing incrementally, one little part at a time, and so it's getting faster by the same amount each time. So in this case, let's look at this first example. While driving his sports car at 20 meters per second down a 4-lane highway, Eddie comes up behind a slow-moving dump truck and decides to pass it in the left lane. If Eddie can accelerate at 5 meters per second, how long will it take him to reach a speed of 30 meters per second? All right, so you've got an acceleration of 5 meters per second. So we do have an accelerated, this is getting faster. So if you remember, when it's non-accelerated, it's rate times time equals distance. Okay. If it is accelerated, okay, then it is, so accelerated, it's going to be velocity equals, so I guess this rate is velocity. So let's put them together. Velocity is going to equal distance over time. Let's do it that way. So this is non-accelerated. But if it's accelerated, velocity is not just going to be distance divided by time, right? Instead, it's going to be V equals AT. So it's going to be the product of whatever the acceleration is times the time, because it's going to get faster every second. So in the second it's going to be that much faster, and then the next second it's going to be that much faster, and so the velocity is going to increase incrementally. If you were to graph this, it's going to go up like this in a straight line. If you were to graph this, the velocity is going to go up faster and faster and faster as it goes. So I'd love my money to go up this way. My money usually doesn't even go up, but this is better because within just a few seconds it's going to be huge because it's accelerating. It's not just going up at a certain speed. Okay, so we're going to use this formula, V equals AT. Now we've got velocity, but velocity, we've got two different velocities. He's going an initial velocity, right? And then he's going to get faster. So I need actually two velocities. So let's just do an obvious one. Velocity is going to be whatever my final velocity is minus whatever my initial velocity is. Because this, sorry, that's initial. So this is actually a change in velocity. We could say the change in velocity is going to be equal to the acceleration times the time. So the change in velocity is going to be whatever its last is. So let's say I go up from 50 to 60. What's my change in velocity? Well, I go from my final minus my initial, so 60 minus 50 is 10, so my change in velocity is 10. All right, that's how you would find it. So that would be that times the acceleration times the time. We're given the acceleration here, 5 meters per second. So let's see what we've got. We're asked to find how long it will take him, so let's solve for t. So we're going to have t equals change of v, and then a has to go on the bottom, divided by a. Well, the change in v is final velocity minus initial velocity. All right, so what is my final velocity? My final velocity is I'm going to 30 meters per second. So that's going to be 30 meters per second. And then what's my initial velocity? 20 meters per second. Okay, so that's going to be 10 divided by a. So a is my acceleration. So I can accelerate at 5 meters per second squared. So a is 5 meters per second squared. Okay. So what I've got here is I've got 10 meters per second divided by 5 meters per second. Okay, so that's a second. That's what second squared means. It's 5 meters per second divided by seconds. So what's going to happen? These two will cancel, and my answers are going to be in seconds. So 10 divided by 5 is 2, and the answer will be 2 seconds. So it's going to take me 2 seconds in order to go from 20 to 30 if I have an acceleration of 5 meters per second. Okay, there's your first one. Don't know if it made a lot of sense to you, but these are the numbers we're playing with. So let's look at this again. This is what you want to see again. When you have accelerated motion, it's the change in velocity equals AT. When it's non-accelerated motion, it'll be velocity, or the change in velocity equals D divided by T. Depends if it's getting faster or not getting faster. Okay, here's number 2. Vivian is walking to the hairdresser's at 1.3 meters per second. Okay, so she's not getting faster, she's just walking. So this is just a normal velocity. She glances at her watch and realizes she's going to be late. Vivian gradually quickens her pace at a rate. So that is anything meters per second squared is your acceleration. So she's accelerating at this amount. So she's getting faster by 0.09 meters per second every second. Every second she's getting faster and faster because she's getting panicked. Okay, so here's our A. This is A. What is Vivian's speed after 10 seconds? All right. Well, if you remember, we had, just from up in the previous example, we had change in velocity equals AT. So it's accelerating because I know she accelerated, so I'm using this. And remember, this is going to be final velocity minus initial velocity. So here's her first speed, 1.3, and then here's her second speed, whatever that is. We're probably going to have to find it. Let's see, what's her speed? So yeah, we're going to find v sub f. Then we're going to know her acceleration. That's the 0.09 here. And then her time after 10 seconds. So we're just going to fill in what we know and what we don't know. So we don't know this. So let's get it by itself because that's what we're trying to find out. How do I unsubtract v sub I? I add to both sides. It cancels on this side. And I end up with v sub I positive on this side plus AT. Okay, now fill in. This is what I'm finding. This is what she started. So I'm going to say v sub f equals 1.3 meters per second plus, now here's my acceleration. So it's going to be the product of 0.090 meters per second squared times time. Time is 10 seconds. Seconds is going to cancel with one of the seconds on the bottom, leaving you meters per second, which is your speed, and that's what I want to find out. So I need to multiply these two. So first of all, I'm going to multiply this, so it'll be 0.90 meters per second. Okay, plus 1.3. So 1.3 plus 0.90 is going to give you, what is that? V sub f equals 2.2 meters per second. All right. Now let's see how fast that is. Is she running, jogging, or walking very fast? No idea. A meter is 3 feet. 2 meters is 6 feet. So this is more than 6 feet in a second. So if I'm leaping six tile blocks in a second, I've got to be jogging. I don't know if I'm walking very fast. Maybe somebody could walk that fast if they had really long legs. I would probably be trotting to do that. So first one here would be 2.2 meters per second, and then this would be jogging. All right, last one today. A torpedo fired from the submerged submarine is propelled through the water with a speed of 20 meters per second and explodes upon impact with a target 2,000 meters away. All right, so it's not accelerating. We can use the old one. What was the old one? Okay, velocity equals distance over time, since it wasn't accelerating. So let's find out what that is. What's my distance? It was 2,000 meters. Okay, and my speed. So I need to change this, right? Because it gives me a speed, but it doesn't. I don't know how long it was. So let's put this in. Can you see that in order to get this out of the way, this is going to come down to the bottom and this is going to come back up on the top. So it's going to be T equals D over V. Here's my D. My V was 20, okay, 20 meters per second, Okay, so I've got 2,000 meters divided by 20 meters per second. When I end up dividing that, so it's divided by, so this is going to end up being in seconds. So what is 2,000 divided by 20? It's 100 seconds. Okay, so 100 seconds equals my time. That's how long it took the torpedo to get to the boat and explode. All right, so 100 seconds. All right, what else does it say? If the sound of the impact is heard 101.4 seconds after it was fired, what's the speed of sound in water? Okay, so the impact happened at 101.4, but it took 100 seconds to get there. So how much time did the sound travel in the air? Does that make sense to you? It took 100 seconds for the torpedo to get there, and then it exploded, and then it took a total of 101.4 to get back. That means I'm going to subtract 101.4 minus 100, and it took 1.4 seconds for sound to return. I don't know if that makes sense to you. I hope it does. This time is part of this time, so I needed to get rid of this to know how much the time was actually in the air, because it's asking me what's the speed of sound. So I need to know how much time that sound traveled. It only traveled the small amount. It didn't travel the total amount. Okay. So it says, because the torpedo is held constant speed by the propeller, the effect of air resistance can be neglected. It's actually got an engine too. It's got a little motor on that. So we can just think that that is normal. It's not getting slower. It's not getting faster. So we can use this d over t. So we've got 100 seconds to get there, 1.4 sound to return. So what's the speed of sound? So the speed, and it's not accelerating. The sound is just traveling at a normal distance. So I can do the same one we did before. Distance divided by time. Okay. I'm trying to find the speed, and I know the time. What's the distance? Okay. The distance was the same distance to the boat to start with. So it's going to be 2,000 meters divided by 1.4 seconds. Your answer is going to be in meters per second, and that's going to be 1430 meters per second. Okay, just keep going, keep going, keep going.